All right, chapter 1. It was a definition of statistics, right? A whole bunch of definitions, right? What is data? What is this, right? We did that first. All right. Good. I'm gonna cancel it out. Okay. Okay. Chapter 1. It was all about. Take a little notes here. 1.2, guys, talk to me. Look at 1.2 notes. What is 1.2 about? Data classification. All the different stuff that we think about as data, right? Two large groups. One is qualitative, right? Qualitative data, and one is quantitative. And then underneath each one of those is the subset, right? Categories, they're not numerical, they're nothing, right? Yes. Then we also have numbers in the qualitative. There's numbers there. But those numbers don't add, subtract, multiply, divide, right? They're like student ID numbers, right? They won't make sense to compute things. Then you got this other area called numbers. Yay, quantitative data. One is 0 actually means something, right? Like a temperature scale, right? 0, you're not at nothing, you still have something, right? That's that one. And then the other one is where 0 actually means something. 0 means you have nothing. Yeah. Two categories underneath two categories. I think that's a good summary of 1.2. Okay. Boom, 1.3. What is that about? It was about how we collect data, right? Or how we design an experiment that actually would go well. There's your two things. So that one's probably the more technical one. Those are the ones you probably have to go back again and like, oh, let me take a look at one thing. There, that's why I have this stuff. Okay, so chapter 2. Chapter 2 now is after we collected the data, we've done the experiment. How do we display the data? So that's one thing. Now, 2.1, 2.2 is all about graphs. We're going to be graphing. Good? So 2.1, 2.2 about graphing, graphic representations. They will include numbers in there as well, right? But they're technically sort of graphing that thing. 2.3, 2.4, 2.5. Now we're actually going to look at the numbers in the data. So today we'll hopefully hit. Okay, good jam. 2.1, are we good there? Wrote it out loud? And I'm going to go back this way. Hopefully the microphone caught me saying all that. Okay, we're going to skip these. Oh, real quick here, those that are new. If you see a highlighted text, that's the stuff you probably should write down most of the time. If you don't see a highlighted text, that's just for us to consider as a function. And I think we do this. No, we don't do it. We do this. Okay, good there. Sweet. Let's jam. Okay, we are going to construct stuff. So don't need to write it down, just for us. We're going to construct stuff like midpoints, relative frequencies, cumulative frequencies, and boundaries. And then we're going to put them into graphs called a histogram, polygons, frequency histogram, and OGIVs. What? Hopefully you've seen this kind of data. And you guys talked about this. And I'll bring in some examples of some recent examples. Okay, let's jam. What is a frequency distribution? It's just a table. It's cut into classes or something that's called intervals. And then all we do is we just put how much are in each category. So, the person who works in the district office called Kyle. I think you got the name from home. Kyle. Kyle ran in the district office. He looks to see how many students are in the GPA of 0 to 1, 1 to 2, 3, 3 to 4. Or even better yet, how many students are above 3.5, because that is considered a honors category, right? Anybody above a 3.8 is considered a super honors category. Okay, and then just some, I figure this, we're going to go through an example. I don't want you guys to do the example because you guys will have some of them to do, right? We're just kind of working on it. Okay, so classes or intervals. Next. So each class has to have something called a lower limit. And an upper limit. So where does it start? Where does it end? And again, statistics, everything actually, is just it's just people coming up with ways to represent the world numerically, right? We're going to do this, right? Okay, lower limit, upper limit. One more thing that we talk about, actually two more things. One is called the class width. Class width is just the difference between the, not how much is in each class, right? But the difference between each of the classes. So notice it's a subtraction from 6 minus 1, right? So it's from one lower limit to the next lower limit, or from one upper limit to the next upper limit. We call it consecutive. And one more, and we're good as far as definitions go. And then we have something called the difference between the minimum and the maximum, and that's called the range. We'd like to see the range. We're going to use it later on. So how wide is all the data? So let's do an example here. All right, maybe the other thing that we should probably write down something called, anytime you see a formula, you probably should write that down as well. So formulas super deep there. And I'm kind of looking to see when most people are done, and all people are done writing. If I go a little too fast, tell me. All right, and you also will be able to look back at the textbook as well for these things too. So. Stuff down, wait just a bit. And again, you don't have to copy the whole entire slide unless you really want to, and you're a fast writer. But at least the stuff that's in highlight. That's important stuff. Cool. Okay, class width is the difference between the classes. That's cool. Range is in the highest to the lowest. Let's start with. Let's just kind of, again, don't need to kind of think with me, good? You can put your pencils down at this point. Right? So constructing a frequency distribution. How do we do this? This is so funny. You have to select anywhere between 5 to 20 different classes, you get, or intervals. That's a usually. In our mind, we think about, like, if I have that much, I can kind of see where the data is. Right? Is it always that way? No. I mean, sometimes we use 4, right? But when you get down to 3, it doesn't make sense. It's too jumbled together. And then beyond 20, it's like too spread out, so you don't really see anything. You really are seeing things. So, boom, we determine the class width. And once we do that, then we divide the range into the number of classes, and then you round it to the next mean. Find the limits for each class. And once we do this example, we'll do the process. Find all the remaining lower limits, that's cool. Find out all the remaining upper limits, that's cool. And then we've got ourselves our little graph. Really pieces. Tally up all the scores and place them in the original. Again, a lot of busy work. Let's go through it. So here's our data set. You don't need to write it down. Kind of think with me here. So data set lists. This is out-of-pocket prescription medical expenses in dollars for 30 US. That's a lot of money. I think that's in dollars, right? Yeah. So like $200, $239, $155. And this is 30 US adults. So it's a little survey. We're going to construct a frequency distribution that has, they even tell us how many classes here. So we could have decided, but they're going to tell us. We've got to put it into 7 classes. A little bit of work here, good. So, I got this one, this one, this one. Let's start with what we need to do. So first things first, number of classes is 7. Very good. Nodding, that's great. Next is find the class width. Oh boy, hold on. I need to know how far to extend each class, right? So here's what I'm going to do. I'm going to take the range, and this one you probably want to write down, stuff in red here. So range divided by number of classes. So if you want to do the numbers, it's fine too, just the data set. How about this class? I'll after class ends today, I'll actually give you guys those numbers there. So you see what the numbers are. It's been 10 minutes right now with numbers. So if you want to put example 1 on here, example 1, and then what we'll do is I'll send you guys the numbers. Cool. Okay, so let's do this here. So the highest number I see is 405, lowest is 155. That's great. Subtraction, we've got 7 classes to do it, so about 35.7 should be each class. So what do? We're just going to round it up to the next class, the next whole number. So 35.7 is a 36. So down. For each class, that's cool. Okay, now let's go. Now let's start. Number 3, use the minimum. That's 155. Now we're trying to do the lower limits, right? 155 would be the lowest one. And so if we add 36 to it, that's going to be the next lowest limit. So 155 plus 36 gives you 191. Good. Okay, now this is up to you. Use the concentration. You copy all this down, or you can kind of take a look at it and kind of make sense. Okay. And as I see across the class, everybody just kind of take a look at the screen, see if it makes sense. Okay. So boom, 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 this one, this one, this one. And then what we do is we subtract 1 from this one. So we've got 191 is done. We're going to take 1 away from that to give us 190. And then 226, 1 away from that will give you 227, 1 away from that will give you 226. So we good. We select our lower limit and upper limit is done. Or what you can do is you can get your 190 here and then just start adding 36 each time. Right? That might be. I think subtracting. Subtracting 1 especially. Okay, let's see what we got here. Then we start tabulating. Yeah, this one just says you can just subtract 1. Or you can go by 36 each time. whichever way you like. All right, and then we start tabulating. We go back to our, usually we do a tally mark if there is any, a tally mark right over here. And then we start labeling how many are in each group. And then the only thing that we can do is we can just check. If we add up all these guys, it should be the number of data I have in the first place, right? I should have had 30 numbers here. Let's make sure that I have 30 numbers here. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 10. Yes, so there was 30 data points I had. And I end up as I count my frequencies, I'm back up to 30. Okay. And we made ourselves a frequency table. Now let's get into some formulas. Good. Let's dig a little deeper. So there's a formula. The way we represent the data, sometimes what we do is we use something called a midpoint. So now this one should have been, it's in red, so sorry, it should have been highlighted there. Midpoint of a class. Sometimes in data points, you actually see the data set up in midpoints. So let's do this for the first one. The first class went from 155 to 190, is that right? So divide by 2, so if we count with it, the midterm of the first unit will be 172. That's the exact middle. So as I show the graph to you guys, you will see it kind of done both ways. Sometimes we graph it in terms of limits, which tells where it begins and ends. Sometimes we just graph it as a midpoint. Okay, once we get that middle, we can do the rest of them if you like. And we keep on doing that for each next one, or you can just add 36 to it. Right, because 36 is the difference between them. So 172.5 plus 36, you do the next one, the next one, the next one, and the next one. You just keep on doing it until you are done, and you have all the midpoints. Okay, so midpoint is something else we do with the graphs. Next thing we do, let's see a couple of people still writing it out. So and please ask the questions if you like, if you need to. Okay, next is, that's the midpoint. Next thing that we kind of want to see is how much, if everything is like 100%, I would like to kind of know when the data falls, like 20% of the data is over here, right? Or 50% of the data is over here. Kind of gives me a lot of quicker view of things. So this next one is called relative frequency. So how much does something show up relative to the whole? Or we say how much of a portion is there, or how much of a percentage is there? And I got a formula for you. Ready? The relative frequency divided in here equals class frequency, like how many times did that class occur, right? Over the sample size. And then notice all these things. Now we get into mathematics here. So it says sample size is n, but on the bottom it says n. Don't forget n is the addition of all the frequencies together. Next thing is show of hands if you went to the library and you got yourself a TI 83 or 84 calculator. Raise your hands. I'm supposed to give extra credit for those people that did that. Okay, if you haven't done so already, during break time, we good? During break time, I need you guys to go to the library, check out a calculator for this semester. Good? TI 83 or 84, which ones did you guys get? Which ones are there in the library? 84? 84, okay, so you can go 84. Okay. Okay, Jim, okay, I got that one. So I want to know how much or portion or percent of it. Now the graph is going to look exactly the same, but based upon what we have on the side, we're going to tell it, oh yeah, we have this much or this much. Okay, next one is cumulative frequency. So as you're adding stuff up, sum of the frequencies from all the previous classes. So you just keep on adding up the previous classes to the next one. Keep on adding, keep on adding, keep on adding. Okay, again, kind of doing this in the theoretical space. Let me show you some numbers, see if it makes sense, and we'll go for it. I will tell you guys on the homework, what's going to happen is you're going to be off like by a single number sometimes. Like, why is this happening? Why is it a 7 instead of an 8, right? And so don't get too frustrated. Just go back, find a number, talk to a friend. All that jazz. Don't be too frustrated. So you just need to figure out why that's happening. Okay. Are we good? This cumulative frequency, you just add up from the previous class to get. So at the end, you should have size n should equal how much you have total. Okay. So cumulative frequency of the class. We're trying to do this here. If we want, maybe we could have. All right, some weird stuff here. 1 second. See more news? I don't want to see more news. Oh, good. Got rid of the. Finally. Okay. Let's take a look at it here. See if this makes sense. This is our big data point now. So midpoint formula. Are we good? There it is. There's a midpoint each one. U4. It's on my computer only, but I could send it to you guys as well, and you can see it that way. Can I do it? Yeah, let's do that next time. Okay, let's kind of see the stuff that's happening here. Real quick here, midpoints and midpoints. Everybody okay with midpoints? Any questions on those? Now the question is, what's the relative frequency here? So let's see. The grand total is 30. Is that right? So if I have 3 over here, 3 divided by 30, it's going to be 0.1 or 10%. All good there. Then we have 2 divided by 30. That's going to be less. That's going to be, and rounding it off to about the nearest. Everybody okay with this being 10%? Everybody okay with this being 7%? 0.07 about 7%. So with the relative frequency, you could do it in terms of decimals or percents. You know, 5 out of 30 is here, 6 out of 30, 7 out of 30, 4 out of 30, 3 out of 30. Okay, and then we have the cumulative frequency. So all we do is we just do this here. We take that little 3 over here, 3 comes across here. 3 plus 2 is 5, and we just keep on adding it up. 5 plus 5 makes 10. So you keep on adding the next one over there until you get to the end, which you should get 30, because that's what you started off with. That's something with, so kind of just double checking. That's a big chart you made, huh? All this stuff just to make sense of the data. Okay, so let's take a look at some graphs now. Oh, let's do this one. Ask some questions here. This is where I get to bug people, is that right? Let's see, which one is the highest category? Which one has the highest frequency? I don't know. I'm going to just try this here. Let's see. Oh, yeah, that's awesome. Oh, love it. Okay, cool. Highest frequency of the year. So that's people that spend about $299 to $334, right? What percent of the people spend that much? About 23%, right? Almost a quarter. A quarter of the people spent in this category, right? That's 23%, kind of close to 25%. So almost half the people are in this category here. And so this one is, so if you include these two right here, from here, that's 20%. That's 20, that's 23. What's that? 43% already, is that right? 43, talk to me. 43 plus 13. 56, so look at that. Almost half, or over half the group, right, are in this category right here. So almost half the group spend anywhere from $263 to $370. That's the big range here. That's very important because you figure you do want to know that sort of like half middle, right, or the majority. That's important step. Questions? How do you find the frequency? This guy? Well, you go back to your data, and it was that little tally sheet over there. How do you tally up? There's 3 in here, and there's like 2 in there. That came from our tally sheet. Like going back to the numbers that we had originally, and just saying, okay, there's a guy that spent $180. That goes into this category. There's a person that spent $200. That's going to go into this category. Okay. We good there like that? Hopefully we'll have. Zoomed in, I can't zoom out. There it is, okay. All right, let's jam. Screen now graphs of these guys. All right, frequency histogram. That's what we're looking at. It's a bar graph, and that removes frequencies, which is exactly what we're talking about right now. So that's what it looks like down there. Ish. Has some other stuff into it, but that's the more important part here. So horizontal scale is quantitative, measures the data values. So don't need to write that stuff down. We'll just kind of get to it. Vertical scale is always the frequencies, and then the consecutive, the bars have to be in order, and they touch each other. So whenever you have data, a number at the bottom, they always touch each other. Okay, one little small problem we got. You know how our, let me go back. You know how our measurement right here goes from 190 to 191? There's technically a dollar space here, right? Because we know dollars also have cents inside them. So we got ourselves a little problem when we do this, because there should not be any boundaries. These guys should touch each other, which means there should not be any space between them, any data space. So because of that, we talked about boundaries. Class boundaries, because consecutive bars of histogram must touch. Bars must begin and end at the class boundaries instead of the class limits. Here, that's the one that gets students frustrated on the homework. Why are we doing this? Why is it this way? Separate classes without forming gaps between them. Can't be a single gap. But the top one is the one. So class limits are different from class boundaries. Class limits are to classify things. Class boundaries are made for our graph, so there's no gaps whatsoever. So how does this work? Back to our table. We don't have to draw this out again. There's our expenses, right? Class frequencies. But now let's add an extra category to this. So on the side here, we're going to do this here. We're going to add a boundary list to it. So 190 to 191. So the middle of that one, the class boundary there would be $190.50. Is that right? So there's 50 cents there. And then there's 50 cents there. So notice now the class boundaries, they are exactly the same. The class boundaries are going to overlap right at that point. And the only thing we got to be careful for is make sure there's nobody that spent $190.50, right? Because they'll be counted for two categories, but they'll be double counted. That's not good. So the class boundaries can't have any data on them. It has to be the middle of the data. I think you guys will do that on the homework, so no need to do it now. So let's jam here. Here are the if you want to do, you can just do add 190, 191, divide by 2. Okay, one little thing is, notice the lower limits. Notice we have the 155. So to stay consistent everywhere, the class boundary has to go down by that much as well. Okay. And then also that 406 over there, that was our class limit for the top. Just to be consistent, it has to go up by the same amount. So now it's 406.50. Dun, dun, dun. Is. And then here's the 2. Right? This is, don't need to graph them. But talk to me. Anybody see the difference between them? The one on the left is using midpoints, is that right? Notice the numbers there are midpoints, 172.5, 208.5, 244.5. Those are the midpoints. The one on the right are using those limits that we talked about, or the boundaries. Yeah, that little broken axis. Notice that. Have you guys ever seen that before in math class? Like algebra or no? When did you guys see it? Brian, when did you have seen that?
It was my freshman year when we supposed to make the graph a bit smaller.
Yeah, okay. Yeah, if you go from 0 all the way to 172.5, that's gonna be a lot of empty space, right? There's no need for that, especially since we don't have any data that goes all the way down to 0. All the data is really mixed in between 155 and 406, so no need to have all that extra space. So that little broken axis. Okay. Janet. There it is, just kind of zoomed in a little bit more. Then we have another thing, something called a frequency polyglot. Instead of having those columns, this is not, it's not used that often. I've seen it sometimes here and there, usually more technical stuff. This one I've seen more of, like, if it has to do with time. Time when we do this here. So this is spending per month, or GDP, gross domestic product over time. But it sort of shows you the continuation of it. Also, I see what's going up or down. Here. All right, I want you guys to notice one important thing that students miss sometimes is notice that the beginning point and the end point is going to be at 0. That's what usually polygons do, especially for this kind of data set. Usually begins with 0 because it gives you like a full picture of something. Another thing that happens in statistics when you guys are doing the homework is you'll be doing something and you're doing it wrong. You're like, why am I doing this wrong? And it's almost like, you know how when you go shopping and you say you get 20% off, and they're like, yeah, that's cool, right? And you go shopping, you come to the cashier and you got like 3 items, right? And then you're like, oh, this one, cool, 20% off this item. And then you're like, oh, how come you didn't take the discount off this one? Because, oh, because on the fine print, it says 20% of all non-sale and non-clearance items, right? Like, oh, what? Right? Because you're going to pay clearance price for this one, right? Or sale price. So that's kind of what happens here. It's going to be say, draw a cumulative frequency diagram. And you draw it, and like, that's the wrong one. Like, oh, because cumulative frequency means this. Relative frequency means this. Shucks. That's kind of what we're looking So these, we're good. But it's gonna be sometimes schools miss the definition with their. Okay, not gonna do it. But if we had our little class boundaries over here, we're going to construct a frequency polygon real quick here. The only thing with frequency polygons is we use midpoints because we're going to have to only use one dot, right, in the process. So by the one dot, the best one to do is just the midpoint. So it looks like this right here. So the stuff in red, graph should begin and end on the horizontal axes. The usual goes up, then it comes down, and then we're going to use the midpoints. So now we've got ourselves a little problem. What's up with the 136.5? Never seen that number before. I haven't seen 424.5 either. So it goes back. That's this stuff right over here, right? So our class boundary was 144.5. So what we had to do now is we had to go to the next boundary line, or actually the midpoint, right? It's the midpoint minus 36. So the midpoint here was 172.5. And then if we were to subtract off 36 here, we would end up with 136.5. If we were to add from the midpoint, 36 would get that one. So it's the midpoint of the class that's above. Class that's below. Okay, we good. Some technical stuff. This is technical drawing so that we get, so everybody's doing the same thing. And this is something just we agree upon. Like order of operations. Right, you guys, order of operations? We multiply and divide first, right? Then we add and subtract. How can we do that? Why can't it be reversed? It could be reversed. It just adds math problems. But because we as human beings, we say, hey, this is the way we're going to do it so that everybody remains the same, everybody's consistent, everybody's doing it the same way. The same thing. Okay, so I probably should do a quick video on these. This you can do this on a TI 84 plus as well. It'll do the same thing. It'll give you like a little video. But I'll do these little video vignettes and I'll post them on the YouTube channel as well. Okay. One more thing to do is something called the relative frequency histogram. All right, has the same shape as the horizontal axis corresponding frequency, yes. And then the vertical scale measures only relative frequencies. So it's those little percents or decimals we talked about. So all this is coming really from just that one data point. The only that changes from us is that's the vertical axis, the y-axis. It's a relative frequency now. Shape is exactly the same, no changes. Let me give you a quick picture here. So we have that right there. Let's give you the relative shape. frequencies. So remember off this side, we had the next category, right? It had 0.01 over here, right? 0.07. It's these little categories here. So everything else remains the same. Looks like they did it by boundaries this time. But here's your 0.1. Here's your 0.7. This one was 1.7, is that right? Oh, sorry, 0.17. And the highest it went, anybody remember the highest it went? 0.23. This was exactly 0.2. And so we said that between these, in fact, you know what? Remember how we counted this side over here? We probably should count this one because this one's higher. So between these here, that's a good majority of the data right there. So from 226 bucks to 334.5. The majority of the data is just sitting right there. That's a relative frequency.
So this is the vertical scale.
Say louder, a little louder.
Is this vertical scale?
Yeah, the vertical scale is these little changes right here. It's this, the fact that this guy here is, instead of just a total, it doesn't say 3 over here, right? And this 2. This is a scale from, let's see if I can find it. It is from this one right over here. Let me see. I should be able to find it right here. This one. There it goes. It's from this little chart right here. That's where it goes from. It's like the decimal or percents of how much we have. And it should total 1. After adding all these guys up, we should 1 because it's technically 100% of the share. Does that help? Okay. That one. Okay. Are we right here? Okay, one last one. One last one here it is. Something called the cumulative frequency graph or something called the phobia. This one is, remember that cumulative frequency one? It's the one that you add the class to the next one, to the next one, to the next one. This is the graph for this guy. It's for OGIV, and you just keep on adding up. Good there? So, let's go over here. So constructing it, I'm just going to give you a whole bunch of stuff to do there, but it's this right here. Remember, from our data point, you look at the upper bounds. That's all we care about. We care about the frequency, and then we care about the adding of the frequencies. This the summation of the previous frequencies together. And so it has to add up to 30, which is our number of data points. And the graph looks like this. Notice it still starts off with the, this is boundary, right? This is the lower bound. So 0 here. and about what 3 here, right? So we get to 5. By the time we get to here, we're at 10 of those guys, and 15 is the halfway point, right? So once you at the halfway point, so half of the people spent 198.5, 298.5 or less. And this is really cool to find sort of the midpoint, the middle of things. And you go higher, higher, higher. Did you guys take the SAT? ACT here in the middle? Okay. So those ones, they give you a percent. Let's say you are in the 99th percentile. That's where this stuff is right here. And once you put percentages in, then you see your score compared to others. Okay, I'm going to stop here for now. So let's take our 10-minute break. We'll come back to do 2, 2, 2, 3. Just finished all the graphing stuff. All right, class, let's keep on going. So this is finish up 2.1, 2.2, descriptive statistics, and as if there was not enough graphs yet to do, how about more graphs and displays of stuff? Now this one's gonna be a little bit different because this one involves numbers and having numbers inside the graph itself, and then the regular stuff that you guys seen before. Pie charts, I think you guys seen pie charts before. And then we're going to take a look at qualitative data. That's the next section here. So let's jam 2.2, more graphs. And we'll just do one quick thing here. Why is it? There it is. Hide the toolbar right there. All right, we tend to call them displays. Like a pie chart, we call it a display as opposed to a graph. So let's jam. So first things first, there's something called a stem and leaf plot. I don't know if you want to graph them completely. And maybe we can just do the like the next slide, but just do a few of them, not all of them. Like, I'll just kind of show what's important here. So stem and leaf just means this: you got a front number on the front, and then the leftovers of the number are in the back. So 21, 25, 25, 26. Notice what we have here. Here's your 20 and the 1. 21. You got your 25, and you got another 25. And you have your 26. That's the one that's kind of bigger. The end of the stem usually is in order. Doesn't actually have to be completely. So the 2 in front is really the 10th place. Right? It could be 100th place, it could be 1000th place, but whatever the number in front is, it's usually stem and leaf plot is you have one more extra little number at the end. That's what you're trying to get to. And usually that happens when you're going from one number to another. So let's say 120. From 20 to 100, right? Gonna have a little, hey, I'm gonna see how many of those. So stem and leaf plot. Just for writing, go for it. So let me just show you an example here. So this is the data set. Don't want you to copy it down. Here's the data set Number of text messages, what? One day for 50 people. Talk to me, guys. Are you in like the 30, the 70, the 100, or 120 category? So how many text messages per day? How many say like, oh, like 30 a day? No, less than that? No, no one for 30-ish. Okay. 50. Let's go. 50. Am I too high or no? Am I too low? Too low. Okay. I'm gonna go 80. 80 per day text messages. 80 per day. Okay. 100 text messages a day. 120. 150. Wow. Okay. Anybody less than 20? Man, I do it. Okay. Okay. Gotcha. Oh, just want to say a little bit here. And so with these, the Pew Research, that's a huge research firm in the United States. They do a lot of different research from cell phone usage, employee data, religion, I mean, all this stuff. Pew is the big, humongous research firm. All right, so here's what we got. The lowest one, gotta go with that one, is 16. The highest one is a 49. Notice, oh, bummer, look at this. One is a 2-digit number. The other one is a 3-digit number, right? But the highest one is one. So would it make sense to put all the 2-digit numbers in one category and the 3-digit in another? That's like only 2 categories, right? That's not cool, right? So I think what I'm gonna do is I'm gonna go to the 10th place, anywhere from 1, that means I'm going to have 1 all the way to 14. I'm going to have 14 different classes or intervals. Is that okay? 14 is okay? I think so. Okay. So now we're going to say, okay, that means 76 is really a 7 and a 6. 149 is actually 14 in front with a 9 in the front. We good? And let's go with it. It looks like this. So the title's up front usually, boom, and then you have this little key right here. And you just pick one of the numbers, kind of show you what it is. And there are 16 right there, 16. And then notice you can kind of see the frequency of it, right? Boom. So there's a major gap of 20s and 30s. Then there's a big one of 60s and 70s. So a lot of people are sort of in this little category. So, out of curiosity, our talks, ready? How many are in the 20s and 30s range? Just I think 4 of us. Okay. How many are in the 70s and 80s range? I kind of would fit into this. Okay, so 1 to 4, so that's 6. 6 out of 50. So a third of the class is in kind of those 2 different. It's kind of like what the data shows. Maybe a little more. Maybe this is more like almost 40%. But it's kind of cool because you kind of see how big it is. Notice they are in order on this one. And most of the time they are going to be in order. Just you kind of see, because sometimes you can say, oh, you know what, it's almost at the 30s, but not quite. Look at all those 9s there. And so you kind of see it through there. Anyways, we good, Stephen? Plus? 1 down. Let's go. Next one. This one is a bigger list right here. That's notice sometimes student lead plots they also give you the zeros just because it's a complete list. Sometimes what they do is they cut it off halfway. So notice the 20s are cut between a 25 is the middle ground. So if you have 5, it goes in the next category. 4 or 0 go into the first one. So split them off. Now we have 28 different categories. Just to sort of see a little bit more of a list. And the stem is shown twice. Okay, we're good there. Okay, let's jump to this one here. More. Another one. Not so much used, but you'll see it. Next one is called the dot plot. So we put a interval out there somewhere. going from highest to lowest, and then we just put dots. And if it's repeated, then we put 2 dots, and we just kind of keep on for those. If you like. All right, we good with that one? That's a fairly simple one. That's just what we do. That's it. And then we tag it. Can you see the frequencies still on it? Yeah. Frequencies are still. Okay. I'm going to run through the next slides here. So there's again text messages going from here all the way to 149. But now you can see a little spread there, right? This stem and leaves are usually vertical, and the dot plots are usually horizontal. Just a matter of which way you want to see it. And then it just says that you can do this with a whole bunch of different. Something called mini tab. Mini tab is something that's done. It's a statistics software. We're going to use a table format there in this class for the most part. Also, StatCrunch is another one that. Another way to do statistics. Okay, stuff we've seen before here. How about a pie chart? Pie charts are pretty easy to do. In fact, there's a lot of calculation that goes into it. Even though they look very nice, I have to do some work on the front end. So pie chart provides a convenient way. It is, it's used a lot. Pie charts are all over the place here. It is to present qualitative data graphically as a piece of a whole, a portion of a whole. Thing that you have to know is a circle of 360 degrees. And then we have to cut it up so that it kind of fits like into that little piece there. So we have to figure out what the relative frequency is. How much does this thing compare to a whole? That's it. Let's do one together. I think we can probably draw this out. So a little bit of work. Let's go into here. So I've got some data for you. Here it is. It's the number of earned degrees conferred in thousands in 2014. National Center for Educational Studies. So a little dated. That's okay. So I got associate's degree. Every good there? Everybody knows what associate's degree is? Bachelor's degree at the university, a master's degree, and then a doctorate degree. This is so cool. So with the doctorate degree, to get actually a PhD, you have to come up with something new in your field. So it's like studying psychology, and studying psychology to the level that you publish or you do something that's never been done before in the field. So then you're like mastering your field of that. There's a lot of people that actually have something called ABD. It means all but doctorate. That means they went to the university, they got all their work, all the classes that are done, but they actually did not produce something new in their field. It's kind of a little lower tier. Anyways, 1,000, 1870, 740, 168. I'm going to let you go. Let me get a little more work here. So we're going to construct a pie chart. Da, 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 da. I'll see your work here in just a second here. Let me give you a little bit of a thing here. So what we do is we have to figure out the relative frequency of how much things occur. And I gave you the first one. So let's go back to our little chart. And let's do this. I'm going to have you guys do this here. Can you make another piece right here? Make another. And then you're going to put relative frequency. Relative frequency. So make one more column. So everybody has a calculator now because they went through right to the library. They got a calculator. It's great. So on the next column, make a relative frequency. And let's try it. Relative frequency. So real quick here, what's the total? Have a calculator, add that up real quickly here. $805, you second that? Cool. All right, relative frequency. Here we're going to take 1,000. 3 divided by 3,800. Let's see, to the nearest. It's going to be decimals, right? Yeah. So let's go 3 decimal places. That would be at least give us a percent. 3 decimal places. Okay, so what? 2. I think it's 0.2. 263. What's after the 3? To the 40. Okay, so it's actually 0.2636. Is that right? Yeah. And so we'll go 2 points. Cool. Next one on the list here. This one's going to be 1,870 divided by 3,805. What do we get there? 490. Yeah, it's about. Okay. 419. Sorry, tell me again. The number here on the calculator, 0.49491, and the next number. Oh yeah, okay, cool. So because that's a 4, it stays the same. So this is just a 4 or lower stays the same. Higher, higher goes up. 754 divided by 3,805. Right? Yeah.
So confused right now.
Go
Sorry.
ahead. Talk to me. Go ahead.
Okay, because I did the same calculation and I got a different number.
Oh, sure, yeah. So which pen?
For the first one, I got.
I got you because you put in the answer. Okay, so it's one at a time. So 103 without 3 divided by 305. Is that better? Yes. Oh no, that was just an arrow. I just drew an arrow saying that's right there. All right. Anybody give me 754 divided by 3,805? 0.198. Okay. Love it. Okay, and then Kimberly. If you have a calculator.
Yes.
Cool, 178 divided by 3805. I know it's a zero from 0. Yeah, 467, so 47. Perfect, okay. We're good. One more piece here that we need to do. And we'll wrap this guy here. We need to know the angle. Angle that we're looking at. So what we're going to do here, we're going to write 0.264 times 360 degrees. And you're looking for an angle that makes that true. Okay, and you know, the pie chart's not going to be very precise. So just give it to me to the nearest angle. Just give me the nearest angle. And maybe, hold on, I got to pick on people. This is the good stuff. We'll have being a teacher. Janet, since you're sitting at the end, go for it. Janet, what's the angle for the first one? Yeah, cool. So about 95. Okay, so 95 and then put degrees there next to it. Da, da, da. Let's see. I picked on Elizabeth already. Jimena, there you go. Oh, Palmer. Okay. Good.
Sorry. What's in the parentheses under angle?
Angle?
Sorry?
360.
360.
Yeah, 360. We're good? Okay. Arla, it is. Go for it, Arla. No. Andrea. We are going to multiply each of these numbers by 360 degrees because we want to know the angle that's there. So you can put like this, maybe under angle, just put 360. Multiply by 360. All right, give me the next one. Let's see. Sorry, Kimberly, where are you? Kimberly? Okay. Give me, you got a calculator?
Yeah.
Yeah, okay. So 0.491 times 360 to the nearest degree. Right there, everybody agree? 176? Kimberly, what does it say? 17, what?
176.7.
Wait, how much?
176.7.
Oh, okay, 176.76, because it's higher, we're just gonna go 177. 177 degrees, okay, boom. Next one to pick on, Andy, pick on you, man. I need 0.198 times 360. Oh, cool, okay, 71.28, so it'll be 71. 71 degrees. Man, data gets messy here. Okay. And Giselle. I think you got an extra zero here, so it's 0.047.
Oh, yeah.
Okay, 0.047 times 360. 17 is cool. Okay, guys, real quick, the numbers are 95 degrees, 177 degrees, 71 degrees, and 17 degrees. Are we good? I'm gonna have Brian do a check for us. Brian, can you add those up? Make sure we get 360, because we better get 360, or else we are computation wrong. So this is kind of double checking our work. Awesome. Okay, you guys, let's construct this little pie chart here. So normally what happens is you just start somewhere. So there's a little guy right here. Usually we do our biggest one first. So it doesn't matter where you start. I prefer starting like right here. That's just me, like right at the top like this. And now I can kind of calculate stuff. Normally what we do is we use the biggest one first, or we go in order. So in order the data is presented, or the biggest chunk first to get smaller and smaller and smaller. So it kind of doesn't matter. The one that's done in the textbook here, it's doing it based upon order. So we'll do that order. So each quarter of a circle is 90 degrees. So this would be 90 degrees right here. And that's not what I want. I want just a tiny bit bigger. So more, tiny, little tiny bit more than a quarter right there. And I'm going to put associate degree. And then what we're going to put in here is the percent of the relative frequency here. So this was going to be 26.4%. Where did I get that percentage from? Which column? 1, 2, 3, or 4? It's 3. It's this guy here. And we're converting this guy to percents. Okay, 177 degrees. So that means that's 180 would be halfway across. 177 is just shy of halfway across. Now, hold on real quick here. Real quick, talk to me. Add up 195 and 177. 195, right? So that means if I were going from here all the way to 180, it would have to be a little bit above 180. Like about, oh, sorry. So if I were to add an extra piece here, it's 180 plus a little bit more. Okay? So it's not straight across, it's just this little angle like this right here. Just a little tiny bit more. Sorry, class. Hold on. 177, because we're counting from here. Like that, right? It would be just shy of going 180 degrees. Oh, it's almost half. All right, this is bachelor's degree, and we got ourselves 9. Cool. Okay, now the small stuff. Master's degree at 71%, and then this guy's at 17. So I'm thinking the slice is not halfway. That would be 45. So like maybe like this right here, would that work about there? Yeah. Okay, this is a master's degree. So master's, I can still write it in here. Master's degree. And that is going to be 19.8%. And the doctoral degree, I don't have, there's no room. So I'm going to have to write it outside. So doctoral, put the percent outside. I can sometimes put the percent inside, but I usually like to have the percent close to the number. So this is so how about 4.7%? And then I'm going to have to put an arrow here. So the arrow says I go right there. Okay, are we good? Dude, our first pie chart. We're cool at that, guys. I think we should do one. And we did. All right, all that's kind of missing here is we should have always a title for it. Right? What is this even talking about, right? Yeah, so this title should come up here on top. To it, so then you know what you're talking about, and the rest of it makes sense. Yeah, interesting. I think it's 2010, I believe. They were looking at this stuff, how many degrees awarded, and they started to look at in terms of the male and female. And so I think 2010 was the first year where there were more females getting degrees than males. And it's consistent from here on out. So for the last 12 years, it's been this way. And so the question is, well, what's happening, right? What's happening to the males? Are they just getting jobs and are they going out of? So there's a whole discussion that happened in like 2012. All the educators were talking about this phenomenon, first time, and really the first time in American history that's happening. So anyways, that was a big deal. 2 years afterwards. Okay, a few more, and then we'll be done here. So how about the next one on the list? Parallel charts. Parallel charts. So one more extra thing. This one, similar to a histogram we covered today, but it deals with qualitative data. So notice one little extra thing here. So notice the little bottom there are categories. They're not numbers. There should never be numbers in the bottom here. These are categories. These are favorite movies, favorite foods. Those are kind of those. So it's always set up for qualitative data specifically. Next, notice that there's gaps right over here now. Histograms, no gaps. With parallel charts, there are gaps now because categories are different from another, right? All right, and then frequencies are your side. So how many grand total? So I'm not going to make you one. I thought the pie chart was at least a fun one to make together. This one I'm going to show you. You'll have the opportunity, if you really want to, you'll have the opportunity to do it on okay. One, two, three more charts to go. And here's how it looks like. The 2014 number of leading causes of death in the United States. Man, accidents. This is United States Health. Yeah, 2015 table. So this should be. You guys say good, bad, ugly? Heart disease is the biggest one. Heart disease and cancer. Those are huge, right? Notice the big disparity between those two, and then the other ones are like at 100,000. I think the accidents account for so many. They're in the top 5. Okay, so let's do this here. Notice they are categories, right? There's no data here. So we go like this. Sometimes they go from highest to lowest. Like I said, sometimes they're just in alphabetical order. Sometimes they're in the order given. In these days, with these days, it makes sense to put it the highest to lowest because they're just different categories. They don't care which way they go. So yeah, heart disease there, cancer, huge. And then you go down. Notice there's no break in our graph because the numbers do not break. Okay. Notice also that on the vertical axis, right over here, it's death, and then they have these numbers, and then we just put them in thousands. So these guys are in so it tells you the scale that you're using. Okay, title for this side always, a title for this side always, and a title for the graph itself. So that one, just funny, just the look of it, it looks like it was done in Excel, just because that's the way Excel. Or at least the previous version. Okay, we're good there. Parallel chart. So we're good. Yeah, 2 more here. Paired data sets. That means we're using one thing and looking at another. So 2 things that are being connected together somehow. right, so you have the x-axis, you have y-axis, and it's always, remember from algebra, this is called quadrant 1, is that right? This is the positive, positive, positive. So as x increases, what's happening to y? That's what we want to see. Makes no sense to go negative on either side because we're counting things on both sets. All right, real quick here. I guess we can do this one again, not graphing it. We this guy in math language and algebra language, this is just called a scatter plot. So paired data sets or whichever one comes up as. Not gonna make it graphic, but here's what we got. British statistician Ron Fisher, he was looking at certain physical characteristics of petals. So the length of a petal and the petal's width. Is this on a leaf or is this on the flower itself? So the question is there a relationship between length and petal? The interesting thing is, let's talk about it. We're not. Does the petal length cause the petal width to become bigger? Yes or no? Let's see their graph. Here's our graph. Point represents a petal length. So this is the length of the petal, right? And this is the width of the flower. So it looks like he has two different species, maybe, right? You got this little dwarf species over here, and then you got the bigger one here. So it looks like the length of the petal length is here. So quick little question. Does this length cause this length to happen? Yes or no? Answer is 2 letters. No. Just because this, notice that there's a correlation here, right? As this gets bigger, this gets bigger. But this, we call this a correlation. This means there's a connection somehow, but this does not give you the connection. Okay? The genes give you the connection between these two. Right? One more real quick here. This one right here, I'm just going to say it. As temperature increases, there's another one here. As temperature increases, no, hold on real quick here. Sorry. As there's consumption of ice cream going this way, there is death by drowning this way. Yeah, seriously. It's like straight up. So consumption of ice cream increases. That means there's more death by drowning increases too, all the time. It's like, so yeah, stop eating ice cream, right? What could be the connection? Anybody? As consumption of ice cream increases, there's a correlation to drowning increase too.
Summer pool.
Yes, it's summer, right? So there it is. Okay, the connection. So the cause is actually people eating ice cream and playing in the pool at the same time, right? But consumption of ice cream and drowning are not causes. Or else I'll stop. You should stop the answer. Okay, time series. And so this one very much similar to a polygon chart, as we talked about, like the polygon chart. Except it does not start at 0. Does not have to end at 0. So there's no shape that's made here. You just start by a certain time period and you end at a certain time period. All right, this one has to be timed, so notice time is on the bottom, it has to be numerical, right? And then you have quantitative data on top. And it could be anything, right? We tend to think about it in terms of like maybe like money or enrollment in school. We actually talked about this in our meeting last week. And how enrollment, like the day that you register for the class you're going to have, right? So before COVID, we tended to, like people tended to have classes about 2 months before, right? That's kind of the semester, right? And so with COVID, there's people rushing in the last minute. That last week is a whole bunch. There's a difference there, the time factor. This is so interesting. Airline tickets. If you guys notice that whenever you buy like airline ticket or a ticket, they increase it. So you look at it one time and then it's more expensive the next time, right? So what the airline business did about 5-6 years ago, they started doing this. They started tracking when people buy tickets. And so usually it's about a month before your flight. For some reason, that's like everybody starts buying tickets. Yeah, I'm going now. So what they did is they have, after they found that out, then they put a price quotient in there, right? A demand quotient. And so then you, with your plane ticket in about a month, the price will spike a bit. So then for each flight, it's different, right? For each flight, you know, everybody going to Alaska is a little different than people going to Las Vegas, right? It's interesting. You view the stats. After the stats, you think about how that's going to affect certain things. But that's it. So we have this data here. Oh, motor vehicle thefts in millions. Burglaries in millions. Let's start the time series chart for motor vehicle. That's just one of them, not both of them. And so it's going to look like this here. So these are in terms of millions. Let's go with it here. And it's going to look something like this. All right, do we have a break in our bottom values? Yeah, we have a break point, right? We're not going to start off the year 0. That doesn't make sense. This now in terms of millions, but notice it goes from 1.4, right? We've got some decimals in here. And then we usually connect these guys. So is this to a certain city? I didn't read that. Or is that just, I don't know where here. Crime in the United States. There it is. So in the United States from 2005 to 2015. It looks like it's true data here. So what's happening that motor vehicle thefts are going down? That's the next question. What's causing that to happen? Can we go down even further? Is this the benchmark that's going to happen here? Are there any spikes? Or is there cities or states that have spikes that we can actually do the same stuff in one state that's really having low numbers and replicate in another state? Or maybe it's a totally different population. You can't do that. There's all those different things that come up. There's always, whenever gun control comes around, right? There's always this idea of whether carjacking, car thefts, whether that's going to have a correlation as well. States that actually have carry laws, they tend to have less motor vehicle thefts than once. So is there a positive or not? So all the good stuff that comes out of that. All about numbers, all about getting to the truth of things. Yeah. Okay. I am going to stop here.